Okay, in this lesson we're going to be looking at our inclined planes. So an inclined plane is one that is elevated at an angle, so it's just a slope basically. So the weight of a body on an inclined plane acts vertically downwards. So if I just draw these forces on here, the weight is still going vertically downwards. So in this example, it's a 3 kilogram mass. So what you've got is 3g newtons going vertically down. Now, if we just look at the side, and we also have got the normal reaction. Now, the normal reaction, the key point of it is this word normal. Now, normal means at right angles too. So here, your normal reaction is going perpendicular to this thing. Okay? Normally, you wouldn't have this diagram. You need to be able to draw these diagrams. So this is something people are not good at all. So to draw an inclined slope, I'm just going to show you how I would do it. And then I'm going to use my diagram at the side to show how we find out a wee angle here. Right. Whoa, there we go. There's a bad example of how to do it. We do a horizontal line, decent horizontal line, a decent slope. We'll mark on our angle. I'm going to call that angle just 15 like we have here. We have our box, which is our thing, our object. The first thing I want you to do is mark on the perpendicular. So this line here, this is your normal reaction, which is perpendicular to your slope here. That is key. So it's perpendicular to your slope here. The next thing you need to do is a vertical line down. Now, what a lot of people do, this is what most people do, they do their line going down like this, or their line going down like this, or worse, their line going down like this. So these are all incorrect. So just be careful with your line. Make sure it's going straight down your page so that it forms a right angle here. So what you need to do is form a right angle triangle. Now what you need to do is continue this line here. So this normal reaction, continue it on down, but once you get to this side, do a wee dash. Okay, and what we're going to do now is we're going to work out what this angle would be. So what would this angle actually be? So to do this, if we know that is 90, this angle in here, can anyone tell me then how would I find out this other angle then? So somebody brave, how would I find out this other angle? I know 90, I know 15, what would this other angle be?
180 minus 90 plus 15.
Yep, 180 minus 90 and minus your 15, or minus brackets 90 plus 15, absolutely, good man. So if we just do that, right, haven't quite woken up, so I'm just going to do this on my calculator. 180 minus 90 minus another 15 is equal to 75. Okay, same person then, James, I think that was. Can you tell me, James, how can I figure out what this missing angle in here is then?
90 minus 75.
90 minus 75, and 90 minus 75, 90 minus 75 will be 15. Okay, now what I don't actually want is this, what I don't actually want is that 75 marked on my diagram. I have no need for it at all. That's really what I want there. But the key thing is here, folks, this angle, whatever it was, say it had been theta, if something is inclined at theta to the horizontal, this angle in here would also be theta, and that is key. And there will be times when that's all you know, you don't know what theta is, you're not given the angle, you will have to work that out. Okay, so on your diagram here, can you do as best as you possibly can, continue your normal reaction line. Let me just do that again, get rid of all that. We'll do your vertical going down here, and then we'll do our normal reaction line, and then we'll continue that on down, and you can see this is 15 degrees in here. Okay, folks, it is absolutely key that we understand where that line, that angle comes from. So, can you put that in here to show where that comes from? But you really should be able to very quickly draw these things now. If that's theta, there's your normal reaction. Do your vertical line coming down, and then that is going to be theta. So that's really how the way you need to be able to quickly draw those diagrams. Right, so key thing is now we've got our normal reaction, we've got our 3g newtons, our weight acting down the slope, and you've got your 15 degrees marked on as well. Right, it says in this one, draw the forces acting on a 3 kilogram mass which is being pushed without resistance by a 15 kilogram force up the slope. Now it's being pushed technically, so if it was being pulled, I would draw it like this. That's 15 going up this way, that's it being pulled, but it's actually being pushed. So if you're being pushed, the force really is coming from the other side, so it's a bit weird. That's what you've got, okay? So that's what we've got going on. Right, now what we don't have to do is do anything else in this question, but just so we can see here. Oh, here, we'll go on down. We'll look at this later on this page, so we won't waste our time on this bit. Okay, so that's all we had to do there. It says, when we want to consider the motion of an object of an inclined plane in more detail, we need to consider all the forces to determine if there are any resultants. In order to do this, we must resolve the relevant forces into two directions. So we want to go parallel to the slope and perpendicular to the slope, or parallel to the plane and perpendicular to the plane is another way of saying it. So let's draw this again. So first thing in this example, this is just on your page 25. Mark on, this is your R. Continue that wee line on down, so it should be straight on through, and then do your vertical line. So that's your weight, which was 3 kilograms, so 3g newtons is your weight. And then that's 15 degrees, and that's what you've got. And remember, you had a 15 Newton force acting parallel to the plane. Okay, now what we're going to do in this question, can you divide your page in two, please? We'll be drawing this diagram again in a wee minute, unfortunately. What we're asked to do in this example is to find the normal reaction. It says calculate the acceleration of the body from an example above as it moves up the slope, and the magnitude of the normal reaction. So we're told there's some sort of acceleration, so mark on the double-headed arrow and the acceleration, and then we also want to resolve perpendicular, resolve, and this wee symbol, sorry folks, I didn't explain what that means. That means resolve perpendicular, so it's a wee horizontal and then a wee vertical line. That means resolve perpendicular to the plane. So, unfortunately folks, I can't really do this too well, or can I? Let's have a look and see, maybe I can, using all these fancy things. No, I can't. Right, if you imagine I'd taken this and I had rotated this, so that this line here was horizontal. So I rotated so that line was horizontal. Then I could figure out what was going which way. So going perpendicular to the plane, don't take this down please, it's just me explaining this, but perpendicular to the plane, you've got a force going this way, and then you've got a certain amount of your weight going the opposite way. So if you're going perpendicular, also there is no force. There is no acceleration in that direction, perpendicular. So that means a force. That means a force going up this way balances with the force going this way. So that's really where we are. So first of all, you've got your force going sort of the upward way was R, and then the force. How much of the force 3g force is going where along that dashed line? So can anyone tell me how much of that 3g force is going along the dashed line? So is it 3g cos 15 or is it 3g sine 15?
3g cos 15.
Excellent, 3g cos 15. So it's going to be 3g cos 15 because you've got the angle, it's 3g cos 15. Okay. Quite difficult to explain online, folks. Normally I'd be showing you how this angle turns around. So if you imagine this, I've got my force and I've got the angle between the direction I want to go. So that's why we're using cos as opposed to using sine. Okay. you would then just work that out. And give that as a value. So R is equal to 28.98 newtons, and that's to 2 decimal places. Okay, next thing what we want to do is resolve, and this is a weird wee way of saying it, but we want to resolve parallel to the plane. And I also put a wee arrow to show anything going up the plane, so that's a wee diagonal arrow is positive. So resolve the wee double arrows there. It's not an 11, it's like parallel, it means parallel to, resolve parallel to the plane. And the wee arrow up the plane means anything going up the plane I am considering as positive. Okay? There is also acceleration, so I'm going to say use F equals ma. Now folks, this is the hardest thing we have done so far in our mechanics. So it is tricky, so please, if you have any questions, do ask. Okay, Big Red, what is my force that is going up the plane, please? What force is pushing this thing up the plane, or pulling this thing up the plane, or whatever it's happened to do?
15 newtons.
15 newtons, good man. Okay, right, now you don't know this bit, but there's a certain amount of the weight of this thing is acting down the plane. So not all 3G, definitely not all 3G if the weight is acting down the plane, but this, but some of it is. So what you have to do is do 3G, and then we don't have the angle to bring that 3G. You can see the arrow I've just fired on. We don't have the angle to pull that 3G round to there. So if you don't have the angle, Josh, do you use sine or cos?
Sine.
Sine. So that's going down the plane. So it's minus 3G sine 15. And that equals my mass. The mass is 3 times your A. So if you work that out, right, Ben, turn your microphone off there, mate. Right. If you do that, then is that Kyle? Sorry, apologies, Kyle. Apologies, Ben. Kyle, turn your microphone off. Right. Here, what we want to do is do this on our calculator and see what. Sorry, is it? Yeah. Oh, that's wrong. Right. Sorry, that's going to be 15 minus 3 times 3 times the 10 times the sine of 15, and then divide that by 3. I've worked out, got my A is equal to 2.41 meters per second squared. So it says in the next part of the question, it says, if the force acting up the slope is reduced by 10, what will happen to the body? So we'll just see what happens if there's any difference. So can you draw that same diagram again? So there's your draw a horizontal line, draw your slope. It was 15 degrees. Draw your body, and it was R as your A. You've still got that 15 newtons. And then do your dashed line along, and then your vertical line down, and that's going to be 15 degrees in here. Sorry, it was reduced to 10. That should have been a 10 there instead of a 15, so that's 10 newtons. And that then is 3G newtons here. Okay, I haven't read the question properly. It actually says it was reduced by 10 newtons, so it's going to go down to 5. So it's going to be 5 there. These notes of mine are an absolute mess. There's so many mistakes in them. Right, okay, right, calculator's out, make sure we get this right, and I'll have to adjust my notes after. Okay, with 5 newtons going up, resolve perpendicular to the plane. Going perpendicular to the plane, there's no change in what the force is which are acting perpendicular, so you've got R is equal to 3G cos 15, so R now works out to be, still works out to be 28.98 newtons to 2 decimal places. Okay? If we resolve parallel to the plane, and again we're going up, and again we're using F equals ma, and we're going to see what happens. So in this one, the force that's going up the plane is 5 just. We've still got our 3G sine 15 going down, and then that is equal to 3 times my acceleration. And if we work out the acceleration this time, so just on our calculators, can we all do that just to check? 5 minus 3 times the 10 times sine, 5 times sine of 15. What I have got is minus, I'll put that in this time, minus 2.7645457 is equal to 3a. And a wee bit of working out then, divide by 3, you've got your a is equal to minus 0.992, we'll say 2 meters per second squared to 3 decimal places. We'll just say, so the body is now decelerating is what's happening. So just say the body is now decelerating. The body is now decelerating. Right, it says a particle of mass 1.6 kilograms is being pushed up a slope by a force F, which acts parallel to the slope. The slope is inclined at an angle of 25 degrees to the horizontal. If the mass is moving with constant velocity, determine the value of F and find the magnitude of the normal reaction of the plane on the particle. Okay, diagram. Okay, you've got your wee box, whatever it is, you've got your normal reaction. It's being pushed up the plane by a force F. The angle is 25 degrees. Draw your vertical line, so that should be a wee right angle in here, and then continue this on down. Okay, can someone shout out please, what is this wee angle I've just drawn? I've got the wee dot at here, what should this angle be?
25 degrees.
25 degrees, perfect. So it's going to be 25 degrees in here. So get that diagram drawn first. That is a key thing for us, drawing that diagram. Get the diagram right. Well, get the diagram right, you're still have a chance of getting the question right. Diagram wrong, we're bait. Okay, right. Next thing, what do we need to do? Next thing, we want to mark on, oh, I forgot to mark on what my weight was. The weight of this object was 1.6, so 1.6 g going down. And it says, if the mass is moving with constant velocity. Okay, constant velocity, if you're moving with constant velocity, what is your acceleration if you're going with constant velocity?
0.
0. So no acceleration. So you're definitely 100% are not using F equals ma. So when we get on to resolving parallel to the plane, we're going to be saying the forces up the plane equal the forces down the plane. That's all we're going to be doing. So, but before that, we're going to resolve perpendicular. I'm just going to pick somebody to do this, please. Can Kyle, can you have a wee go, please? Resolve perpendicular. So you've got a force going this way, Kyle, and you've a force going this way.
Right.
Yep, I can hear you. What have you said?
Not yet. Don't know what I'm trying to work out, to be honest.
Right. You're doing the force that's going this direction first, Kyle. So what is the only force that's going this direction of the arrow that I've just drawn? The green arrow.
R.
R. That's it. Okay. So R. Okay. And then I'm gonna put a red arrow on. And the red arrow is going this way. So what amount of that 1.6g is going that way? I mean, is it going to be 1.6g cos 25 or 1.6g sine 25?
1.6g cos 25.
Cos 25. You're absolutely right. Why did you say cos instead of sine?
Because it's with the angle.
Yep. Excellent. That's it. And that's as simple as it is. It's with the angle in that direction. So it's 1.6 cos 25. Okay, you then work it out, and can we all work this out to get some sort of agreement? As you know how bad my answers are at the minute. 1.6 times 10 times cos of 25. Do we agree with me? 14 to 2 decimal places, 14.50 newtons to 2 dp's.
Yeah, good. Perfect, so good.
Happy days, happy days. Right, I'm getting there, get a bit better. Right. Next thing what we're going to do is we're going to resolve parallel to the plane. And we're just going to say here, no acceleration. No acceleration. So forces up the slope equal forces down the slope. No acceleration, so forces up the slope equal forces down the slope. Shannon, can you tell me what force is going up the slope? So, up the slope. Yep, F. So, there we are going up the slope. So, it's just F going up the slope. Going down the slope, so we'll do that in red. So, going down the slope is this bit of the weight. So, I don't have the angle. So, what is it going to be, Shannon? 1.6g what then?
Sine 25.
Sine 25, and that's it. So just do that, bang that into your calculator again. 1.6 times the 10 times the sine of 25 is equal to 6.76 newtons. And again, and again that is the 2 decimal places. Kilogram mass is being 100 kilogram mass is being lowered down a smooth inclined plane at 51 degrees to the horizontal by a rope. The tension in the rope is 700. Find the acceleration of the mass. Okay, your diagram again, decent size diagram. 51 degrees. Mark on your wee box. Do a vertical line, so make a wee right angle show that's a vertical line, and that was 100g. You've your normal reaction. It is being lowered down a slope. So I'm going to put my acceleration going down the way this time. If it's being lowered, the rope is still acting up the slope. So the rope is still acting up the slope. So that 700 is going in line with the slope and upwards to lower it down. And the one thing, very important thing, which I forgot to put on, is this wee angle in here. This wee angle in here. So mark this wee dashed lines, and this is your 51 degrees. Okay. So that's your diagram. Get your diagram done, please. Just we don't need to do perpendicular. We could just say resolve parallel to the plane. Resolve parallel to the plane, and I'm going to take anything going down as positive. And I'm also going to use F equals ma. Now, what you've got is your force going down the slope is this component here. So it's this bit here is what's going down the slope. So what's pulling you down the slope is a 100g sine 51. So 100g sine 51. What's going against that, what's sort of preventing it just firing down the slope, is a 700. And then that is equal to 100 times your acceleration. So let's just work this out on the calculator and see what you get. So 100 times 10 times sine 51, then minus that 700, works out to be 77.1459 ... is equal to 100a. And then when you divide that by 100, what I've got is 0.77 meters per second squared, and that was the 2 decimal places. The last example says a car of mass 0.6 tons. Now a ton is 1,000 kilograms, so 0.6 tons will be 600 kilograms. So a car of mass 600 kilograms effectively accelerates at 3 meters per second squared up a hill, inclined at 10 degrees to horizontal. The engine of a car produces a forward thrust of X newtons against a constant resistance of 3 newtons per kilogram. Find X. So let's do our diagram first of all. So our diagram, using the wrong color, our diagram is as follows. So you have your horizontal line, do your angle, it's 10 degrees, and there's your car, there's your vertical, there's your R, your normal reaction, and always mark on the normal reaction. Quite often, as you'll find in this case, we don't need it, but that's what we have. And the mass then was 600 kilograms, so 600 G newtons acting down the way. And we also have got your X, which is pulling you up the slope. It's accelerating up at 3 meters per second. Per second squared, I should say. And this bit we need to figure out. The resistance is 3 newtons per kilogram. So, if the resistance is 3 newtons per kilogram, what is our resistance for this 600 kilogram object, how do I work it out? So, James Nicol, how would I work that out, please?
600 divided by 3.
Not divided by 3?
Times 3.
Times 3, yep, because it's every kilogram gives you 3 newtons. So it's 600 times 3, which is going to be, so here just say, 600 times 3 gives you 1800 newtons. So that's where this comes from. So 1800 newtons is going down the slope. So 1800 newtons or 1800 newtons is going down the slope. Now what we want to do in this question is resolve parallel to the plane, going upwards, and we're going to use F equals ma. And then over to you, please. We'll go for Lewis. Can you tell me what's going up the slope, please?
X.
Good man. And what's going down the slope?
Minus 1,800.
Yep, that's one of the things. Right, a lot of people will stop there and think, well, they found it. There's also I'll do this in red, the component of the weight, which is acting down the slope. So very importantly, the component of the weight is what?
600 sine 10.
Almost. You've missed something.
600G.
Good man. 600g sine 10, and that's equal to your mass, which is 600, times your acceleration, which is 3. So that means x is equal to, I'm just going to fire this thing and this thing across the other side. So x is going to be equal to, and I'm just going to show all my things. I haven't done anything. I'm just going to fire this all into the calculator in a minute. So 600 times 3, and then you've got your 1800, and then plus your 600g times sine 10. And do that all in one go in your calculator for a big finish today, folks. So 1800 plus, 600 times the 3 plus 1800 plus 600 times 10 times sine of 10. And there I've actually got an answer right today, which is great. 4641.89 newtons to 2 decimal places.